Hi class, today we're going to go over quadratic functions and transformations, which is found in section 4-1, part 1 of your book. Our goal is to graph quadratic functions. So our first key concept is just talking about the parent quadratic function, how it's set up, what are some of the properties about it. If you notice here, the definition says the parent quadratic function is f of x equals x squared. Its graph is the parabola shown. The axis of symmetry is x equals 0, and the vertex is 0, 0. So just breaking that vocabulary down just a little further, the parabola is the name of that shape of a graph. So the graph that looks like a U is called a parabola. The axis of symmetry is the axis that splits your parabola or your graph or the shape of your graph directly down the middle to form two symmetric halves. Okay, and then the vertex is either the highest or the lowest point of your graph. So in this case, our vertex is 0, 0. And so for parent quadratic functions, the vertex is always going to be 0, 0. All right, so in example 1, we are graphing a function of the form f of x equals ax squared. So again, this is of the form of a parent function. So we can go ahead and assume that the vertex is 0. So since it's 0, then to determine what the other ordered pairs are, we just choose values surrounding 0. So we should create a table. So we should choose an x table, the function, so f of x equals 1/2 x squared, and then our f of x column. Okay, and then I said choose values that surround it, so we're going to choose -2, -1, 0, 1, and 2. And actually, I'm going to make this even easier on myself. I'm going to choose even numbers, and I'm choosing even numbers because I see my denominator as a 2, and so to deal with that fraction nicely, we want to use multiples of 2. So I'm going to actually deal with instead -4, -2, 0, 2, and 4. So again, these values surround 0. Okay. All right. So all we're doing is substituting so that we can get the correct ordered pairs and graph our or plot our points to form a graph. So that would be 1/2 times 4 squared. So order of operations would tell us to do exponents first. So 4 squared is 16, and then half of 16 is 8. The next one, we'd have 1/2 times -2 squared. Excuse me, that was -4, by the way. But -2 squared is going to be 4, and half of 4 is 2. 0 is real simple. Substitute in 0, it's always going to be 0 when you're multiplying. The next one is 1/2 times 2 squared. 2 squared is 4, half of 4 is 2, and lastly 1/2 and then 4 squared. 4 squared is 16, half of 16 is 8. So now I go to graph. Okay, the first ordered pair is going to be -4, +8. The next one is -2, +2. The next one is 0, 0, then 2, 2, and then 4, 8. So again, it's a U, so it should be of the shape like that. Pretty bad at parabolas as far as drawing, but you get the general idea. So again, when we have graphs of the form where they look like they're similar to the parent function, we can assume that the vertex is 0, 0, and so we choose values surrounding. Let's try this again. So in try 1, again, both of these examples are in the form of, they're both in the form of the parent function. So we are going to go ahead and choose values that surround the vertex, which is 0, 0. So again, I'm going to create a table. I'm going to ignore the second one for now, just focusing on this first graph. And then I'll come back and erase this to deal with the second one. Okay, so if the vertex is 0, and this one isn't a fraction, I'm just going to choose a plain value. So -2, -1, 0, 1, and 2. Okay, so then if I start substituting, that's 2 times -2 squared. Again, order of operations says that exponents go first. So -2 squared is 4, and 4 times 2 is 8. The next one, we have 2 times negative 1 squared. Negative 1 squared is 1, and 1 times 2 is 2. All right, the next one is 2 times 0 squared. That's obviously going to give you 0. And actually, it looks like we're getting the same values as the last one, which is perfectly fine, except this time we notice that our x values are different. So it'll look slightly different, not exactly the same. So here's this graph. Okay, the first one is negative 2, 8, negative 1, 2, 0, 0, 1, 2. Okay, the dot's not showing up, and then 2, 8. So this one we notice is a lot skinnier than the last graph. Remember, the last graph was 1/2 x squared, and this one is 2x squared. So this one's a lot skinnier than the last graph we just dealt with. Okay, so now I'm going to erase this so that we can deal with the next one. Oh no. Well, it looks like I kind of made a mistake when dealing with my graph, so I can't actually erase all of it. I can only erase most of it, and that's okay. So what I'm going to do, just kind of cross that out since we can't use it anymore. Okay, so I'm still going to use this table to a certain extent. So our values, since this is a fraction, let's just go through negative 3, 0, and 3. That'll show us what we need to see. And again, I'm using factors of the denominator so that it comes out nicely. So negative 1/3 times negative 3 squared. Negative 3 squared is 9, and 9 divided by negative 3, which is the same thing as multiplying times negative 1/3, is going to give us negative 3. Negative 1/3 times 0 squared is 0. And then negative 1/3 times 3 squared, again, that's going to give us the same, because if it is a axis of symmetry, our outputs should match surrounding the center value. So surrounding the vertex, our outputs should match if we're dealing with a parabola. Okay, so I'm going to graph this one pretty quickly. And so this is negative 3, 0, 0, and negative 3, 3. So this one, again, we notice is pretty wide compared to that 2x squared. However, this one is now turned upside down. So to answer the final question, it says, what can you say about the graph when a is negative? A would be either this 2 or this negative 1/3. So they're asking, what can you say when about the graph when a is negative? You can say that it reflects about the x-axis. So reflects about the x-axis. All right. Okay, so now we're starting to talk about reflection, stretch, and compression. So reflection was what I just mentioned. Our regular parabola would be, or the parent function would be y equals x squared. So when we make the a negative, it flips over the x-axis. Okay, but we did not talk about stretch and compression. So stretch was like our example where we had 2x squared. I said it was kind of a skinny graph compared to the 1/2. Well, now you can see them side by side. The stretch is fairly skinny, right? Stretch is right here. It's fairly tiny compared to compression, which is kind of wide. So always think about it with your arms. You stretch, stretch, stretch to the ceiling. And then when you think about compression, you're just imagining something very heavy weighing your hands down. Okay, so stretch and compression are your differences. So stretch is when your a is a number greater than 1, and compression is for when a is a number between 0 and 1. Okay, all right, so let's keep going. All right, so on example 2, it's asking for us to graph each and then describe the translation of the parent function, which is f of x equal to x squared. So let's go ahead and graph. So again, we need to create a table. And again, I'm just going to deal with this first function first, so g of x only. So let me fix that. So x, and then g of x equals x squared minus 5, and then g of x. Okay, so x would be, and since we don't really have to deal with too much, let's just stick back to our regular numbers. So -2, -1, 0, 1, and 2. So that would be -2 squared minus 5. -2 squared is 4, and 4 minus 5 is -1. -1 squared minus 5, that's 1 minus 5, which is -4. Okay, if we keep going, that'd be 0 squared minus 5. That's going to give you -5. And remember, they should be the same values, but let's just make sure. 1 squared minus 5, well, that's again 1 minus 5 is -4. And then 2 squared minus 5, that's 4 minus 5. That's going to be -1. Okay, so we then go to graph those. Okay, -2, -1 is here. -1, -4 is a little lower. 0, -5 is even lower. 1, -4, and 2, -1. Okay, so what we notice here, as far as our translation, is that our graph has been translated down. It has been shifted down, and specifically it's been shifted down 5 units. So 5 units. All right. So let's look at our next graph, which is h of x. I need to erase all this. So let's erase this. All right, so for h of x, we'll do the same thing. So h of x, oh, excuse me, I need to fix that. Oops. Oh, oops, didn't mean to do that. Oh, come on. Okay. Okay, thing. Sorry, it's giving me a little trouble. All right, so x, then h of x equals x minus 4 squared, and then h of x is going to be our graph. And again, I'm going to choose the same numbers, -2, -1, 0, 1, and 2. Remember, after 0, it should be reflective on the other side. So here we go. -2 minus 4 squared. -2 minus 4 will give us -6. And -6 squared is 36. All right, if I keep going, I should have -1 minus 4. -1 minus 4 is -5, and -5 squared is 25. If I have 0 minus 4 and it's squared, that would give me -4, and -4 squared is 16. Lastly, 1 minus 4. 1 minus 4 is going to be -3, and -3 squared is 9. If I do 2 minus 4, 2 minus 4 is -2, and -2 squared is 4. So now we've run into something that poses a question. Have we truly found the center? And actually we have not, and that's exactly what I wanted to show you. We are not going to actually find our center here. So let's keep going with our numbers because they're getting lower. So we're trying to figure out when it's going to bounce back to the other side. So let's keep going. If I have 3, that'd be 3 minus 4 squared. 3 minus 4 is -1. -1 squared is 1. If I do 4, that's 4 minus 4 squared. That's 0. Okay, so let's see. One more. Let's do 5. If I do 5 minus 4 squared, that's going to be 1. And then 1 squared is 1. Okay, so really our center where it bounces back is right here at 4, 0. Okay, reason being our graph has been shifted 4 units in a certain direction. Now let's see what direction that's going to be. So when we graph, and I'm not going to do all of them. I'm going to start right about here. So that one is going to be 2, positive 4, then 3, 1, then 4, 0, and then 5, 1. So as you can tell, it would have continued to go this way. And so it has been shifted to the right. So within the parentheses, if I see a negative, that means it's going to be shifted to the right. And in this case, it was shifted to the right 4 units. So in this case, we may not want to use that -2, -1, 0, 1, 2, simply because if your vertex is not on this axis, if your vertex is not on the y-axis, meaning you would get, you would use 0 as your center, then you won't get the values that you really want for your graph. So again, let's make that decision now. Based on our past experience, what can we say about these graphs? Well, I can tell from past experience that g of x will actually be just fine. It's not going to shift left and right because to shift left and right, you have to have your set of parentheses. So let's keep going. So I choose my x values. I choose g of x equal to x squared plus 3, and then g of x. All right, so x would be -2, -1, 0, 1, 2. That would be -2 squared plus 3. -2 squared is 4, and 4 plus 3 is 7. Then -1 squared plus 3, that's 1 plus 3 is 4. And then 0 squared plus 3, that's going to be 3. And then if I do this again, it's bouncing back. So this one's definitely going to be 7. So when I graph, I do -2, positive 7, -1, 4, 0, 3, 1, 4, and 2, positive 7. So our graph here, once again, has been shifted on that x-axis. This time it's been shifted upward. It has been shifted up. So it has been shifted up 3 units. And I can tell that because on the outside I see plus 3. Okay, let's do the last one here. So I need to erase, 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 erase. Alright, so x and then h of x equals x plus 1 squared, and then h of x. Alright, so here, let's take a look. We have x plus 1 in parentheses squared. Remember that parentheses should give us a hint that we're not going to have a vertex of 0, 0, simply because it has been shifted either left or right. Now, if we remember our last example, we were given, let me see. In our last example, we were given x minus 4 squared. Okay, so that minus 4 technically shifted it to the right 4 spaces, so it went opposite of where the sign is. So in this case, we have a plus 1. So that plus 1 must mean it's going to shift us opposite of what we think. So normally when we think positive numbers, we think to the right. But in this case, it's going to shift our graph to the left 1 unit. So our vertex should be centered around -1. So let's choose values surrounding it. And let's see if I'm right. Because I could be wrong. I do make mistakes, but let's see. All right, so let's do the first one. So we have -3 plus 1 squared. -3 plus 1 is -2, and -2 squared is positive 4. -2 plus 1 squared is -1, and -1 squared is 1. -1 plus 1 squared is 0, and 0 squared is 0. And it looks like I'm right because after that 0, it normally gives me a hint that I'm probably going to bounce back to the other side. But let's just make sure. 0 plus 1 squared. 0 plus 1 is 1, and 1 squared is 1. Finally, 1 plus 1 squared. 1 plus 1 is 2. 2 squared is 4. So I was right. So remember, if you're trying to figure out what place to start at, you need to determine where is your vertex, okay? When we're dealing with the parent function, it's kind of nice to be able to know that for the most part your vertex will probably be at 0, 0. When we're dealing with our basic graphs. When it's just being shifted up and down, that's fine, but when it's being shifted left and right, you have to really focus on what values to choose, simply because that vertex will give you different values other than what you may want. All right, so the first one is -3, +4. Next one is negative, oops, that was too far out. All right, so -3, +4, -2, 1, -1, 0, 0, 1, and then 1, 4. So it's exactly as I said it would be. That's a little V-ish, but it's definitely a U. It's exactly as I said it would be. That +1 actually shifted our graph to the left. So translated left 1 unit. So when you see parentheses, go left or right, opposite of what you think. And then when you see just the positive or negative at the very end of your equation, that's kind of like looking at a y-intercept, okay? And we will choose to shift our graph up and down. Guys, that's it. If you need any help or need some tutoring, come see me.